Good afternoon. I don't know if you all saw my announcement, but here we are. I actually do have a bandage on my head. Happy to talk about that if people have questions. But otherwise, let's get going today on today's stream. So we have, we have a few things to do. And we're going to pick up our xargs replacement that we started last week. But one of our viewers, who was very active last week, thank you so much for your commentary during the stream, sent me a pull request like an hour after the stream or something. So we're going to start by looking at that. And I think that that contribution is really helpful for us to be able to move forward, and we'll make good use of that. So let me get going here. So let's look at the PR that was sent. So it says fixed infinite loop of null splitter and some tests. Love tests. Thank you. So he was originally just trying to add some sanity tests, but they revealed an infinite loop. So this PR also fixes that. So let's have a look. Okay, so just change that to pub crate, not a big deal. Or remove the pub crate. So for the next, saying if there is a position where the byte is 0. Okay, so this could be none or some, right? If there's none, and buffer is empty, return none. Okay, so that means we've gotten to the end, right? And then you return the entire buffer and set the buffer to the empty slice. Okay. Okay, so it's not actually returning here. This is just getting the slice of the buffer that will be passed through the UTF-8 chunks. So, okay, so if there is an index, then you split out that index, and then you've got setting the buffer to be the rest of that essentially, and if there's if the buffer length is 0, then you obviously give an empty slice here. But otherwise, taking the thing after that index, the null index, and slicing to the end. Okay, and then it's take UTF-8 chunks like we were doing, call next on it, and map valid, because we only care about we only care about the valid UTF-8 chunks. And then there's a bunch of tests. So this is great. And we don't have any CI for this, so I'm going to pull down this branch, and we will can I pull PRs? You know what? Let's just merge it and then run it. I think it's good enough. Let's go with it. Okay. And then I'll pull, and we'll get started. And let's just run tests real quick. Nice. Okay. Nice improvement. Thank you, Ofer. I hope you're joining us today. If not, we'll see you sometime soon. Okay, so what I wanted to do today was look at, can we get multiple processes, and it's too warm in here, can we get multiple processes going at the same time? So there are a bunch of things that I was thinking about how to do this. We can do our own spawn a fixed number of threads and give them give them commands to run. We're going to have to change how we run this in general, of course. But then we could also do something like rayon, or is it crossbeam? There's some crates for. Let's go to crates.io. So like rayon is good for doing work stealing parallelism. This is actually a pretty good fit. And we could, let's have a look at the docs real quick. The interesting thing about this particular problem, what we're trying to do is we're trying to get them going in parallel, right? More than one invocation of the command at a time. But we also want to be able to communicate back to the main thread about some things. So we may want to do like an additional thread that just coordinates the parallelism. But let's see what we can do here in rayon. And I definitely want to get ratatui in there because I was just this morning watching someone's tutorial about ratatouille, and it looks really nice. So, and I know everybody's talked about it, and like, that's really, really neat. I'd love to get going on that. So so we could use this iterator because we already have the split, right? Right, and so we do par iter. And then you get a lot of the same things that you get off of iterator, or very similar things. So I think into parallel iterator is implemented for iterator. Or it's implemented for vec, which I guess, well, no, but we have our own. Let's see. Yeah, it's not, I don't think it's automatically implemented. But we could. Parallel iterator is a trait. Let's look here. Scope. Okay. Let's see what the prelude includes. Okay. Not that surprising. Okay. Okay, let's look at the examples. I think we're going to want something like scope. Right, so you can do spawn and so forth. Hi, Chris. Welcome to the stream. I didn't really get to catch much of your stream yesterday, but I'm really enjoying the stuff you're getting going on your shaders and your puzzle game prototype. That's really cool. Okay, so we kind of I feel like we want to do rayon scope, and then we probably want to use some kind of thing for each thing that we read off of the input. We want to kind of queue it into the thread pool. So yeah, I suppose it's a bit rough because there's some like old state and a GLTF that's causing issues in the debug ended when I re-exported that. Isn't that always the case? Oh man, that's rough. Okay, so we could spawn while we're I don't think so. Spawn, what does this return? It doesn't return anything. So I think this is just kind of fire and forget, which is probably not what we want. Let's look at join. Oh, that's 2 operations. Okay. Let's see, in place scope. We don't want broadcast. Yeah. Yeah, my code doesn't work. Doesn't look wrong. What the fuck is the problem? Yeah, okay, so scope FIFO. Let's look at scope FIFO. No, we don't want a FIFO. We want in parallel, right? We don't care about... Yeah. I should have read up on Rayon before we started this stream. But let's go ahead and add it and see how far we can get. One of the things that yeah, let's see. No, we don't want that. Like, I think the answer is here in iter. And I guess seeing that, like, it wasn't clear whether their parallel iterator was implemented on all iterators. But I think that we might be able to feed the output of our splitter into some kind of parallel iterator. Yeah, I don't need to look in the plumbing probably. Okay. Well, let's start by doing cargo and rayon. No. I don't know why that happened. Okay. Yeah, crossbeam was what the thing I was thinking of. It's inside of rayon. We might be able to use crossbeam directly. Let's really quickly look at that. See, rayon core. Okay, so this is the scope join. Let's look at the dependencies. Crossbeam deck. Yeah. Okay. We're gonna give this a shot. I don't know how it's gonna work, but we're gonna try. So instead of this 4 item and inputs, let's do use rayon prelude. Okay, and then and then let's try to do instead of 4 item and inputs, let's do inputs.par iter. Nah. Par bridge. Bridge from this type to parallel iterator. Okay. One thing that's not clear to me is if we need for each or if we can just do regular loop. I think we need a closure. And then we'll put this in here. I really don't like this process exit from inside a thread. We'll have to come up with something different. But we can try. Oh, right. We can't do question mark here. Let's do expect. Command could not be spawned. Okay, that's another thing I don't care for. So we'll need to figure out some other way. But we can try this. Let's cargo build, see if there's anything wrong. Looks like I need to restart to update Z. And then let's do foo, bar, baz, quox, so forth. And this is dumb, but cargo run. Oh, okay. And so we need to do, let's do echo. Okay, so they did print out in different orders because it was in parallel. So at least we got, the parallelism is fine. We might want to do something like check that this command is going to be okay before we go in here so that we're not needing this expect. Because status returns an IO result of an exit status. Okay. So that IO result could be anything. That's a problem. Interestingly, I didn't have to put move on that closure. Okay. I guess because it doesn't have any mutable references, it's fine. So let's do find target type F. Let's limit it. Target debug type F depth 1. Oh, well, I'm in the wrong directory. Why am I in that? Okay, here we go. Now that command should work. Okay, so so there we got a different kind of command. And let's put our -0 here and put in our find command print 0 just to make sure that stuff is still working. Or was it? What did we make that command? Short was -0, right? Oh, I need the dash. Okay, so it still works with null, which is good. Okay, so we're no longer doing one argument. Well, we are doing one argument. We could do something like we had in xargs there's an option of like number of arguments. So we could add a new one here short is n, long, and we want default is 1. Default, I never remember that. So this is an args, which is going to be a usize. Cargo run help. No, dash dash. Yeah, it needs to be a string, I guess. Okay, I'm going to put a number of inputs to pass to the sub command at a time. Let's see if that yeah, okay, so then it shows default 1. Okay, so now we can do something like this should, I'm guessing Rayon also has this chunks like thing that you get from iterator. So let's look at parallel iterator. There is no chunks. Okay, so yeah, so index parallel iterator, you know how many are there at the beginning. Yeah, okay, so I has to be an index parallel iterator. So that's not going to work. What we could do is before we call parbridge, we can call chunks, which is just a Rust standard library one iterator. Except they're not sorted here. Oh, is it not? Do you have to have... So there's like next chunk. Let's look. Yeah, there's array chunks. Ugh. Why did I think there was one? I think it was actually like, Chris, you remember some of this stuff when we were working at Fable on the animation engine. Like the frustration of a lot of things in here not being, or like they were defined on slice but not on iterators. I think it was like mostly a performance or like consistency thing, but it was super frustrating. Yeah, nightly for every... I mean, I don't blame you. Oh, sometimes I'm just like, every other language has this. Why don't you have this, Rust? I mean, like array chunks is kind of what we want. You know, it has a const generic there, but you have to have that turned on. I mean, this is what we want. Honestly, I think we just turn on nightly for this project. I don't see any reason not to yellow it and then put the feature in the crate. Okay. What is Rust toolchain.toml? Or I could just do cargo plus nightly. to do stuff. Did I get that backwards? Yeah. Feature. Not that. We need iter array chunks. Here we go. I'll just copy that. Okay. Let's do it. And then we need to, may not be used, may not be used. So I think I can put in cargo toml. Been a while since I did this. Let's do. Let's see about how to enable that. Okay, Rust enable nightly. Okay, so toolchain channel nightly. There we go. Rust toolchain.toml. I knew there was that file. I just couldn't remember what to put in it. Okay, fine. New file. I broke my command line stuff, apparently. Rust toolchain.toml. Okay. And then rust up. We'll do rust up update real quick. It's going to have to download nightly, of course. Luckily, I do feel like a lot of these utility functions are pretty stable and are just waiting for a champion or some niche ed case. Yeah, like that's the thing that kind of bugs me about a lot of this stuff that has just been there for literal multiple years. And like, what's holding back stabilization of that? Is it like, sometimes it's like, oh, there's actual features or, you know, stability things that they haven't fixed. And then there's other times it's just like, well, people quit working on it or something. So, yeah. All right. Well, let's see. I might need to restart my LSP here. Yeah, I know. I told you here. Restart language server. Okay, so no, I restarted the language server. Now it knows it's on nightly and it's not complaining about this anymore. Okay. Cargo build. Okay. So now we're going to do, the problem is this, that is a const. We can't do const if we have that in a, we could implement our own. We might need to do that. Honestly, the implementation of this should not be that bad. So let's just go ahead and do it. I think it's worth it. Okay. So we need it as a method on splitter. Let's just call it chunks, which is going to take, actually it's going to consume self. I think most of the iterators that do that do consume self, and then like num items is a usize, and that's going to return chunks. Interesting. There's slice chunks. I don't think that we can directly construct that. That would be sweet if we could. Yeah, it's created by the chunks method on slices, which, like, that's exactly what we want. The thing is, why this... okay, so I think I understand why like a generic chunks on iterators doesn't exist, because it has implicit allocations, right? Here, with chunks on slice, you know that that memory is already allocated, so you're just providing different windows into the original slice. There's no allocations needed. For a generic iterator where you don't know where it's coming from, you have to allocate a vec for each chunk, and then as you consume things from the underlying iterator, you have to push into it. Like, and I can understand why that's a thing that they don't want to do necessarily in the standard library. Now, array chunks, like, part of it, I think, is that it has a const generic, so you always know how much is being allocated per iteration. That's probably why. And I mean, let's just look at the source of this. That's for slice. Oh, that's interesting. As chunks. Hold on. We were looking at that's on slice. Wait, array chunks. Okay, so there's chunks exact. That's also on slice. Okay, so give me the one that's on iterator. Here, fine. Let's just go. Yeah, I think there's probably. Let's look at the source of this. Okay, so it takes a iterator and there's a remainder option array into iter. Okay, and it has to be, you know, n has to not be 0. Yeah, and here's the thing, is like the item is the inner item of this original iterator that it's wrapping, and array of size n. So, oh, that's interesting. Self try for each. Controlful break value. Okay, so trifold. Where's this init coming from? Okay. Fold. I'm assuming the try for each is implemented using the trifold, which is how I do it in a functional programming language. You can do all of the other things with fold, right? Because it's most generic. Okay. What's not clear to me is where this next... Oh, the next chunk, we saw that. That's on iterator. Here, let's just jump to... That's also a nightly API, right? advances the iterator and returns array to next value. So you probably have to supply some generic on that. Yeah. Yeah, regardless, I don't think that we are going to be able to do this without allocating. So that's a thing. And note that this is const n. We can't. Here, let's just do splitter chunks, and that's going to be, it's going to have a tick a in it. I think we can't pass like num items in a generic because it doesn't know what that is at compile time, right? And so it doesn't know what the return type of this is. This is like not doable. So let's make our own. We can stay on nightly. I don't mind, but so we're going to say pub struct splitter chunks, and this is going to take take tick a, and this is going to be why don't we rename this chunk size, and we'll say chunk size is going to be a usize, and then we're going to have iter is going to be a splitter a. Okay. And then here we'll just do splitter chunks, and that's going to be iter is self and chunk size. Okay, and then we need to impl iterator for splitter a, or splitter chunks. Let's put this down at the bottom. Oh, above the tests. Okay. Okay, and then the trick here is the item. Item has to be a vec of tickaster, because we have to allocate, right? Like this is the trade-off we're making. If we were using the array chunks from the standard library or anything like that, even on nightly, we would not allocate. So what we will do is potentially we might do a loop. Let mute we could do self.iter yeah, let's do it like this. Okay, so let's do let result self.iter dot take, and we're gonna do self.chunk size, and we'll do collect. And if let's see, that should be a vec here, vec of right? Is empty, return none, or we can just say none, else some result. Okay, so what's wrong here? Right, so this is moved. So this is the other thing, is that we need to do cloned. Yeah, that's not... Yeah, we're not going to be able to use that. I was hoping that this would be the shortcut, because then obviously this mutates the inner one. We could do something like, is there a split? Partition? No. Because I would like to do, you know, take and rest. Take is the easy way to say, just give me n elements, right? Up to n elements. You know, all these are, they consume. That's the issue. Which makes sense. Yeah, so like take consumes the iterator. Skip consumes the iterator. We can do by ref. Let's try that. By ref. And that will work because a mutable reference of the thing that implements iterator is also an iterator. Yeah, and there's the exact example of what we want to do. Okay. All right. Okay. So we are. So it's gonna return mute self, which, yep. Love it when a plan works out. A-team situation here. Yep. Okay. So that's actually not so bad. Now the caveat here is we are allocating, so we have to take that into consideration. Is that going to be a problem for us? I think honestly no, because we're already reading the entire input. Now we will want to switch to a stream input at some point, like using read and so forth. Standard IO read, right? But for now we're reading the entire input, so we're not under memory pressure. YOLO. Let's do this. Okay, so now we can go we can go back to main and we can say chunks dot parbridge. And now we can say items, and chunks is going to take our args, or options dot nargs. So the default is 1, and then, and let's, before we go too far, let's make a test for our chunks iterator. And here we're going to say args is going to be items, right? So now it knows that's a vector rather than just a stir. Okay, so let's make a test for our chunks. Test chunks 1. And then let's use one of the examples up here that's already been made. Okay, let buffer is that, and then we're going to say, yeah, and we're going to do splitter null on run that. Chunks 1 collect, and we need to make sure this is a vec. I understand now that the format of the test that he was doing here, and then it's like we can assert over the contents of this. So result, and we'll do vec, and that's going to be vec, you know, nested vecs, and we're going to have foo in one, and bar in the second one, and baz in the third one. Let's run that test real quick. Fine. Okay. Whatever. Cargo test. Well, it's in main.rs line 53. Okay, so chunks 1 is fine. Let's do a very similar one, and we'll call it chunks incomplete. So there's a trailing chunk that is, let's do 2 here. So we should get vec foo bar and vec baz. Okay. So I think that's pretty much good enough for knowing that this works. Honestly, there's not that much code there, so I'm not worried. Yeah. We could do some optimizations later. This is good enough for our purposes. So now we can support, say, like passing. So let's do echo foo bar baz, cargo run, and we're going to do N2 echo. So we should get foo bar printed on one line and baz printed on another, but them running in parallel. Right, so baz happened first. That's fine. We don't care, because that is part of the point. We want to do this in parallel. I heard that is chunks, and I love that name for an API much more. I would totally make an API called chunks. That sounds awesome. Okay, that's a pretty good spot to do. Let's add a little bit more documentation here. Set of inputs, additional, I'm just going to put extra commit lines in there, arguments to the program, after which the inputs are added. Maybe just make inputs are added after these. Let's do cargo run. Right. Arrgs. I feel like, you know, you all may see my like pirate flag back here. I was kind of into pirates for a while, so this program is a bit fitting. Also the extra R for Rust. Could have done rargs, but then it's more like that should have been RAWRGS. But okay. So let's add the whole thing. Honestly, here's the thing though. We don't need this feature anymore, but there's no reason we can't be on nightly still. So let's make sure everything's good. Okay. So we're going to add parallelism via rayon and chunk inputs. Now, the other thing that we could do here is like, if arrgs is 1, we don't need to call chunks, and it's just overhead. The other thing that we could do potentially is you know, there's number of concurrent subprocesses is really actually threads per se, because everything in this for each would be like, it would need to be completed before the next one. But we'll figure that out in a bit, because I think that the next step should be we'll refactor this somewhat, because we want the sort of core loop of breaking up the inputs and farming them out to subprocesses to be separate from our display. Now, right now, even though these are running in parallel, there's like a mutex around standard out. And what I would prefer is that we don't have these subcommands print to standard out. Instead, they feed their output as it's received to a main thread, right? And that main thread will manage the display. That's the ultimate goal of this, and like why I even have been talking about Ratatouille. It's going to be, we're going to make something that's interesting in the aspect of how it displays. Now we could just ship this, like this is fine, but you don't get correlation from the set of inputs with the what am I trying to say? With the output that's shown, right? So we should have some way to correlate those, and this is most important for like if you're running some program. For example, the thing that motivated this project was that we had a shell script. It was running some other commands across all the files in the repository to validate they're the right format and that they, you know, conform to a schema, so to speak, and like there's nothing wrong with that. So that was done with just, you know, find and then piping that to a while read loop in a shell. And I tried using xargs on it, but which was fine. It sped it up to get it in parallel, right? But then it was like you've got output interleaved, which we saw, you know, up here when we'd run the command ourselves. We're still doing that, right? We've got interleaved output. But if something failed, you couldn't tell, you know, that the whole script would exit non-zero, which is fine, but you couldn't tell what was wrong with, or what was associated with that failure necessarily. Luckily, I think in this case it's maybe like poorly motivated in that there weren't that many lines, and you would see the line where the failure happened, but it still might be interleaved with outputs from other commands. So my goal would be to have each subcommand get a panel of some sort, and, you know, if it exited, you know, 0, we'll highlight the thing in green. If it exited non-zero, we will you know, highlight in red, and then maybe like auto collapse the output from the ones that succeeded, and have an option to like page through all the invocations. Maybe you only display as many on screen as you can fit, and then we use like the arrow keys or page up and down and so forth to flip between them. And that should be we should be able to structure this such that there will be an option to turn that on. Maybe even an option to pretty print it without the interactivity. So like run to completion and only collapse the ones that succeeded. Something to think about. And of course we should be showing output as it's happening, right? So that's going to be a challenge too. Anyway, that's where I'd like to go with this. Okay. Flag. Okay. So that's a good place to put a commit. All right. That is an interestingly, I think there's probably nothing wrong with our splitter in that case. It can be send. Yeah, I mean, this is borrow OU8, and the other one is split white space, which is borrowing a stir. So references are send. Cool. All right, so I have this open. We might as well look. Let's look at Ratatouille, and we'll start adding it, I think. The issue is currently we have a very like simple command line tool structure, which is like, read our arguments and standard in, and then work through them and then exit. Having a TUI is a very different kind of pattern. So we might want to have some flags here that will be oh yeah, there's also, we might want to add the number of let's look at that parallel iterator from Rayon again. Let's see if we got it. Rayon. I think that there was something on there like number of processes you could set, or maybe that was on the that was somewhere else. I think it was like a global. Let's go back here. So that was max num threads. I think there was a way to tell it. Yeah, current num threads. Might have to use like a scope to do that. Let's see what we can do with scope. No, it's just spawn and spawn broadcast. Is it? No, it's a struct. I thought it was a trait there for a second. I mean, we could do build a thread pool. Start with default. there's a thread pool builder. Yeah. I don't know that we need any of this, really. I mean, we could do num threads and just start at most this number of threads. You know, like, this is fine, select number of threads automatically. There is a, if you look at the xargs documentation, you can tell it how many subprocesses, like p max procs. And here it's like, if you set it to 0, run as many as possible. But if you don't set this flag, then it runs sequentially, as far as I understand. We also don't have the substitution thing. This is pretty useful if you need the argument before something. We haven't done that yet. Note that I think if you use this, let's see. No, okay. I was going to say, I think if you use this, it's going to do only one there, but that's not true. Yeah, only the first occurrence of repulster will be replaced. Okay. It's weird, the defaults for this. Like, why is that 5? I don't know. Okay, what's that -x flag? Exit, right. Interestingly, if you omit the program, it uses echo. Okay. Sometimes these things are so weird. And this is like for lines, using a line delimited mode instead of just white space. Okay. All right. So I don't know how valuable this is to change right now. Especially if there is like the risk here, I think, is you could set this and then it still might be smaller because it's gonna, Rihanna is gonna decide, I'm gonna spawn as many threads as there are CPU cores or something like that, which is a reasonable thing to do. Yeah, number of logical CPUs. You can set the environment variable, obviously, but they're saying there's no guarantee on this behavior, right? The default behavior may change to dynamically add or remove threads as needed. Yeah. So I think let's not mess with that this time. Let's play with Ratatouille. And I honestly almost want to make a new, or maybe we comment this bit out. Let's see. Or maybe we do an execute thing, like split it out into a new module. And we'll definitely have to redo our splitters when we go to streaming. Like, I think there's a possibility that we will have to do some kind of complicated stuff with IO read in that. Or we'll just, just delay that until we absolutely have to deal with it. Okay, so let's maybe just make a function that will do this, right? And let's make it in a new file. Okay, and we'll do mod exec. And let's put that over there. And we'll have to, maybe what we could do is like take this and see if it'll extract into function. Yeah. We'll want to change what the arguments are there, but and we'll need standard process self command. And instead of args, let's just split up the things that we need. So let's do program is going to be a stir. And args is going to be a slice of stir. Yep. Okay, and then we can just say this is args and this is program. And program. Let's rename it program args. Program args. And then it's consistent across there. And actually we can do something like this. Program args. And we can get rid of the command, the extra things there. All right, and then let's rename this to exec. Not great, but okay, so down here we can do exec, and it's going to take options.program, options.program args. Program args is, oh, it's string. Okay, so we'll do string. Cool. Okay, so now it's a bit split up. This is somewhere else, and we can start to think of how to do this slightly differently. Now there's the issue with this for each is that we're waiting on this to complete, right? Like this is enqueue all the work and don't continue until this is done. So this, if we're going to build a UI for this stuff, it's going to have to be in its own thread. This I think I mentioned that earlier. What's not clear to me is if we could do that with Rayon and just spawn it. so let's go ahead and add the rayon crate. I don't know if I have it in here. Let's add rayon. Rayon croissant? What? Okay, and then let's add ratatouille. And we're going to need cross term because we're going to use that as the back end for ratatouille. Okay, and it's going to take a while to generate those. And then I won't have to keep going to the website. It's fine. I don't mind going to the website, but it'd be nice to have them locally. So let's look at cross term. It's going to be at the end here. So we'll be able to do stuff like handle keyboard events, deal with scrolling. Pretty good stuff. But a lot of this is handled by Ratatouille, so we won't have to use that directly except for a few things that it exposes through its own interface. Okay, so let's go ahead and do this number. And before we do that, let's add source. Now let's go ahead and make another. Let's make sure that this still executes correctly. Yeah, okay, it's fine. So this is still session 2. Factor out the execution of subprocesses. Okay. Easy place to do a commit. All right, so if we're going to start with Ratatouille, we need to potentially restructure our app pretty consistently, because Ratatouille, like, it changes the interaction from being terminal mediated into being raw, and that's how it gets, you know, it handles the fast changes of the screen and stuff like that, and how it lets you intercept all sorts of inputs. If you ever used anything like you know, here I use lazy git all the time, right? It's doing something similar. It's going, we're going to take over the whole terminal window, and we're going to redraw it with these frames and whatnot, and then we're going to intercept all the keys. So, like, you can hit Control C there, but it's likely the case that lazy git implemented the Control C handler. So what I would like to do is have kind of 2 modes. And we'll make a flag for this. Let's make let's call this display mode. And we're going to do, we're going to make an enum here. And it's got to derive Saturday deserialize. I wonder if there's actually a something in clap that we can use directly. But what I want to do is make an enum here. enum mode, and we're going to have simple, and this is, we're going to derive default, and we'll mark that with default. And then we want to have grouped, and then we want to have interactive. And let's start with that. Oh yeah, I have to add, even though it's part of clap. Let's see if we can do something with clap directly. There's like a derive for an argument type. Macros. I think it's actually clap derive. Subcommand. I don't want subcommand. All right, let's go here. You derive parser. We already do parser, adding arguments, flags. I don't want that. Yeah, it's not really a, I mean, it is kind of a subcommand, but I want it to be a flag, right? Because I want it to default to the simple. Arg. I think we can use that default LUT actually. And our other one. Okay, enumerated values. Oh, value enum. Okay, so we can derive value enum. That's what I thought it used serde, and it might under the covers, but we can do value enum. And I think you need copy, clone, partial, equal. I don't know that you would need partial ord. Let's add those. Okay. So doesn't implement debug. Fine. Arg. All right, so let's see what that is. Mode, simple, grouped, interactive. Yeah, now there's also a possibility here, and let's look at what right, so this is going to need to be value enum. It's interesting it added, no, I guess it was on both of them. Can I just do default? I thought by implementing default it would use the default. Yeah, there we go. Okay. So we'll probably want more information on this. Right, so simple being the default, this is basically what we do right now. And then we'll have grouped, which will be like, let's show the UI, and but you're, or maybe what we'll do with that is, I kind of don't want to like do screen blanking. That's one of the things that's most annoying to me about programs like pagers like less, is that you can get the screen blanked, and then like it goes back to your command line. You can't see what was in the thing before. It's not in your scroll back buffer, so we may need to handle that. It might be easiest to do the interactive one first. So okay. So I think let's go and split this out into another function, and let's do simple, and options is going to be args, and that's going to return a result. And we'll just factor this out so that we can do multiple implementations here. I think that's going to be the most straightforward way to go. At some point I'll pull in anyhow, because this is garbage and you should not do this. Okay, so then we'll do the args parsing on the main thread, and then we'll pass it to, or on the main function, and then we'll pass it to this. So let's put this in simple, and then we're going to do match on options.mode. And so simple, we're going to call simple of, and we're going to pass options, and then the rest of these we'll do to do, and it'll just crash. So let's do this one. Make sure everything's working just fine. Okay, but now if we pass mode grouped, the other thing that I might want to do is have some exclusive flags. Maybe we'll do like an arg group or something. I think that's what it was called. And have like, you can have one of these flags but none of the others, and then it'll end up being turned into a mode. But we'll see about that. So if we do this, it should, yeah, panic, like not implemented. That's what we expected. So let's do the interactive one next, and we'll start to build our ratatouille stuff in here. So, oops. Okay. So we're going to make a commit here. And we'll say break create a, what do we call this? Execution mode, and break up the main function. Okay. So now, like, now we can think about, you know, this is like the straightforward execute as similarly to the xargs command line tool as we can, and then for the other stuff we can have a more interesting structure. So let's go ahead and make the interactive one. I think it's gonna be super interesting. You know, we may even move this exec, because this is like, we're going to have different implementations of this too. So we may actually move this to that module and rename it. Okay, so let's make a new file, interactive, and we'll start to put the stuff in there that we care about. So, ratatouille, here we go. Let's have some fun. Okay, so we need to think about how we're gonna lay this out, and maybe I'll just start making some comments here about what we would like to do. So I would like for each invocation to kind of be in a frame, so to speak. And we'll have some kind of spacing or like a border at the front. And then there's a question in my mind about like what the title of that thing is. But then we should have, while it's active, we'll have gray text, args, right? And then here will be lines of output, right? And then if one is completed, maybe we'll put a check mark. I don't know. We'll see about that. And then it'll be green text args, and then there won't be any. And then if it's we'll have an X, and we'll say red text args. We'll see about that, and so it'll be like that, and then we'll have lines of output. So we're gonna have to manage. One of the things we're gonna have to do is have to manage how many lines are on the screen, and then when we get output that like, oh, this command completed, we'll want to collapse its panel. So I think that that's going to be, if it goes from this state of I'm printing output to this state, we might even have something where we show a maximum number of lines, like 5 lines or something like that. And then what I'd like to be able to do is use like the arrow keys or page up and page down to flip between these, and maybe arrow keys between per invocations, and then page up and page down for the output, and you could hit space to toggle the display of things that are completed. So let's do let's start to codify some of those ideas into some data types. So I'm going to make a struct process, and this is going to have it's going to have an output which is a vec of strings, probably. I think it's going to have to be owned. We could, and the reason I say that is that we're likely going to have to manage these things. We're probably not going to get stirs. We're not going to get 0 copy on this. And this will be, maybe let's call it like output lines. Yeah. There will be a challenge in here in that these programs might emit their own ANSI codes, which we'll have to be really careful about. So we'll think about that. The other thing here is that these might not be valid strings. If they have ANSI codes in them, I guess they'd be fine. Those are just like slash, bracket and so forth. But I have a sneaking suspicion that they don't conform to UTF-8. We'll have to think about that. Okay, so we're going to have arguments, which is going to be a vec of string that we're getting from from the iteration, right? So like we here, you know, we're getting the splitter and we're taking a certain number of chunks and so forth. It'll be similar to that. Okay, so we'll need to track args that are being sent. And then we're going to have a it's going to be similar to this status thing. I think okay, so if this is terminated by signal, it will return none. Let's look at this exit status ext. Okay, so you can get a signal. We should probably define an enum around for ourselves around exit status, because this is kind of you know, obviously if like we want to maybe and this could go in the interactive file. Yeah, let's do status is going to be process option process status. So we know if it's still executing, we'll have a none here, right? If it is done, we'll have something here, and we just need to define what that thing is. So I think we want to do success, failure, and then let's give an I32, I think it was. Where we go? I was just in my editor actually. So status returns an IO result of an exit status, and then if you call code on it, it will return an option of I32. So it is an I32. And we'll have signal and use that. These are Unix specific, and that's fine. I don't see us running this on Windows, because we are implementing xargs, not, you know, something equivalent on Windows. Signal option of I32 and stop signal. Let's see. So signal, the process returned by signal returns that signal. If the process was stopped, so stopped versus terminated. Ugh. Okay. I have no idea what this is. Okay, so maybe what we can do is let's any wait status return the wait family system calls. A Unix wait status can represent a Unix exit status, but can also represent. Okay, so let's say it's just a signal, and then let's use process exit status. That way, if we don't get it, you know, we can have it debug or whatever. Yeah, this implements debug. We can just print out something with right. So we could do something like, you know, success. That might be a little bit more intuitive. And if it's not success, then we try to get the code. If the code is none, then we put the exit status into that signal thing, and then we just debug this booger. Okay, so we're going to derive clone debug. Okay, and we need to make sure that interactive is a mod up here. Interactive. Okay, so at least this is reachable, even if it's like I'm not used. Okay. So let's make a function which is run, and we get the args, which is super args or crate. And this is going to return a result of, and here's where I may need to pull an anyhow because I'm tired of writing that. Anyhow is a good crate, bruh. So let's add anyhow. It's good for programs. Don't use it for libraries. Okay, anyhow result. Yeah, I don't blame you. Mieti, I have that in my documentation, obviously here in my crates that I have pulled, but I haven't really used it. Or is it Miet? I don't know how to pronounce it. Okay, so it's diagnostics. Interesting. Okay. I don't know that we need this yet, but it's good to know that it's there. And that IR crate. That's kind of a command line or ANSI code stuff for logging. They're all basically the same at basic usage. Okay. Let's look at this IR crate. Okay. Error handling and reporting. Yeah. Okay. Well, I'm going to use anyhow result, and then I think I'll go up here and we'll change this to anyhow result. And then we'll change this one to anyhow result, and that's fine. We will move on with our life and be happy. Okay. And let's go into exec and do that. Oh no, wait, it just bails. Okay. Okay, so we'll put okay in there. So we need to do the basics of initializing Ratatui. So let's just go to the tutorial real quick, and okay, so we've got Ratatouille. So we need to do, I don't know, do you need this? Or you just need the Ratatouille init? I think we just need that. Oh, this is very similar. Okay, so this is like that, like anyhow. Okay, so let's do something like this. And that does not return a result. Interesting. Okay, so then we'll do let result is, well, we've already got a run. we'll just pretend that this is a block, and we'll put OK in there. And then we want to do ratatui restore and result. Okay, so we'll do something interesting inside here. The main thing is that we want to go into a loop, and we're going to have some app state, but we'll figure out what that is. Okay, let's go next. Just flipping through. I have watched most of a tutorial about this, so I'm not completely out of my game here, but we will. Right, so we kind of need to make an app struct which will hold the state that we care about. So let's make a struct app, and I don't know what's going to be in it yet. And let's derive default. And I guess debug. I hope we never have to print it out, but okay. And then we'll do, let's do exit handling. And yeah. And then we're going to have we're basically going to have the list of all the processes that sub-processes we've run, right? As part of the app state. And which is why I made this struct first, to like think through this problem. All right, well, let's do fine. Derive debug, my dude. We don't necessarily need clone, but let's real quick. I said real quick. It won't be real quick. I was going to say, let's see if we should exit by checking whether all of the processes that are in here have non-zero, or have something filled where the status is not none. That's like all complete. I don't know what I was doing there. Discard those changes. Okay. So we've initialized ratatui. We can make a run method on that, and that's probably what we'll do. And we want to give it, I think we want to give it the args. I don't know why I call this args. Why don't I call it like CLI or options or some garbage like that? Okay, and then we want a terminal, which is going to be this default terminal from Ratatouille. And it's going to be anyhow result of that. And here's where we'll do one thing that we may need in here is like we may need to capture the args into this app. We'll see. No, wait. Run and terminal. Let me be mute. Okay, so here let's return okay, right? Just for now. And default terminal is default terminal. It doesn't need to be public. I don't know what it's complaining about there. Let's have a look. Unused variables, method not found on this struct. Method name run. Does it just let I didn't save it? Oh, I know. It needs to be that. Yup, missed that all-important mute self. Hi, Isaac. Welcome to the stream. Okay. So let's look at the tutorial. So there's we need a draw thing. We need to handle events. I think that we're going to have to do an input thread as well as a thread for collecting results. The interesting, so we'll probably use MPSC for that sort of thing. So let's go ahead and let's do this. Or can we just... Yeah, I think I'm thinking about the loop of what we did over here in our our simple implementation. We need to get an identifier of some sort. And I would love it to be an index into this vec. So it should just be a usize. But it doesn't need to be stored here. It needs to be stored in like the process's internal information. So yeah. How are you? I'm well. Hope the bandage is nothing too serious and you have a good recovery. Thank you, Isaac. That's very nice. It's not serious. I didn't talk about what it actually was at the beginning of the stream, but I'll take a break now and mention, since we're almost at the end for today. I had a skin tumor on my scalp. It's a basal cell carcinoma. That sounds like, oh my gosh, scary cancer. Yes, but also the treatment is to do surgery to remove it. And the effectiveness of that surgery is like in the high 90+ percentile. Percentile is not the right word. Percentage of full cure is like high 90%. I think it's like 96 to 99%, something like that. So it's very unlikely that that particular tumor will recur. So as far as I know, I'm cancer free. The only thing I would say, the lesson I would take from this is wear hats, wear sunscreen, protect yourself from the sun. It's not a, like, this is what happens. Now, it's on my scalp. I was like, how did I get that? I wear hats a lot and so forth when I'm out, but it probably could have started happening when I was much younger. So it was scary, yes. But the treatment isn't that bad. And it's not scary in the sense that this is something systemic, that it's not going to be under control. Like, it's in the skin. The skin is very good at healing itself. So, they did have to cut it out. I had to be stitched up, which is why I'm still in the bandages. It wasn't like you can leave it open sort of wound. It was big. They not only had to cut out the tumor itself, but they had to cut an area around it so that they had space to stitch it up. So yeah, I'm okay. Next week, when you see me on the stream next week, I probably won't have the bandage. I'm getting my stitches out on Thursday. So yeah, let's try to finish up a little bit of a something here. You know, we're not doing any of the actual work of this yet. But what I want to do is, hi Ofer, it's fine. Thank you for the well wishes. I appreciate it. What I want to do is just get something drawing on the screen, and then we can end the stream there. I think that's a good spot. So we're gonna do something like, you know, we'll do a non-threaded version. This time we'll just draw something, and then we'll come back and actually implement the thing that we want to implement. So let's do that. Yeah, okay. So this is draw, callback, handle events. Okay. That's pretty typical thing that you would do. Okay, so that's a good place. We need to import that. Let's do anyhow result. There's no reason why that needs to be a. I guess it can be IO result. That's fine. I don't standard IO because these are, yeah. Okay, so we need to render something. Here they're making this. There was a picture of it on the previous page. They're making this counter up and down thing. So maybe what we could do is do a maybe we can get this when this is debug printed. I guess it's derived, because what I would love is to turn it back into the arguments that were passed. But if this implements parser in clap, maybe what I'd love to do is get a formatted version of the command. So if we implement parser, so it just implements parse from arg matches command factory. Yeah, there's nothing on here that will let us directly reprint. Now we could just do standard env args os and put that as the, yeah, let's look at that. Hello? That's not what I want. Give me standard env. Fine, be difficult. Okay. So args os yielding os stirring. I think that we need args. Right. Yep. Okay, so let's make a little title. So over here they were doing, you know, render. So let's make a title similar to this, but we'll make this like we'll collect the args os. Okay. Let's say let title is going to be, and I think is there a ratatouille prelude? Please tell me there's a prelude. Yes, haha. Thank you so much. That's gonna help. Okay. So we're gonna do a line from. Let's do standard env args collect. It's not going to like that. Let's do vec. Okay. Okay. So actually we need to do map into map. We'll do from. Okay, so now it's just because this, like regular stirs, you have to call into on them apparently in this form. That's fine. We might want to do, so this returns, the args iterator is string. We could do intersperse. Ah, nightly. You jerk, Rust. Why are you such a jerk? Okay. We're going to enable this. I want intersperse. It's too good. Okay. We're already on nightly. We're fine. It's fine. Everybody, it's fine. Don't worry. Feature. Okay. And then we can do... nightly only got him. Yeah. Okay, so I want to do intersperse. And we'll do a string from space, just interspersing with spaces. Okay. So yeah, that's right. Item and clone. Okay. Easy peasy. So then we'll have a title. And okay, so they're making a block, bordered block. They're adding the title and saying centered on it. We don't have a title bottom. Okay, so this feels a little bit like building, you know, components in a front-end framework, which is fine. Yeah. Okay, so this is the render function. Oh, we're implementing widget for app. Okay. So I am getting ahead of myself. So I was looking at the wrong thing. So let's yeah, this is where we were. Let's implement widget for app. Okay, so render, and then let's put the title in there. I would rather not do this all the time. Maybe what we could do is set the title when we initialize the app. Okay, so let's go ahead and make a block. Let's use mostly their example. And I know we're like running up to the end. But let's go block bordered. Title is title. Dot left aligned. Bold white. Okay, we'll start with that. Okay, border set. Okay. Oh, that's cool. Did you all see that? Let's type that again. Set with thick line width. Double. There's no dashed. There's no thin. What other constants are there? It's not going to let me jump to definition. Okay, modules, border. Okay, full. Okay, so that's like super fat. So plain is like this. I think plain is nice. What's the difference between that and thick? It's thicker. Okay, let's do plain. Okay, going back to the tutorial real quick. Okay, so okay, so you would display text as sort of like a text area in HTML or something, and you give it a list of lines, it looks like. Okay, so then we're going to make a paragraph. Or I wonder if we can just render the block. Does block render? It does. Let's just do that for now. And let's see what happens. So now we need to go up here. Right. Okay, so we'll do frame in the draw function. We'll do frame render widget self frame.area. Okay. Okay, and then this is, we're just gonna say okay for now because we're not going to do anything in handle events. Although what we need to do, oh cool, you can write a test. Handle events. This is more than what we want to do. And you know, this note here is relevant to what we'll do next time. We'll put the event handling in a separate thread, and what we'll do is we'll feed the main thread with either things from the subprocesses or key events or something like that. Let's just copy pasta this. I don't see any reason not to. Oops. Okay. Why is that not imported? There's something they did with the imports up here. Oh, okay. So they're doing all this. I was importing the prelude, which apparently doesn't have everything. Okay, so that's cross-term event, not ratatui event. So let's just get this up in there, and then we'll be fine. Okay. And then we were down here, handle keyboard events. Okay, so we'll just do this and move on with our lives. And we'll refactor this next time to actually do the things that we want. And then let's, okay, self.exit. Right, so we'll do that. I don't, why did they bother with that? Why don't they just say self.exit equals true? I guess if this gets bigger, you want methods rather than, you know, inline code. But Okay, so now the issue is we're not calling this. So let's go back to main and let's do interactive run and pass args. Okay, and now what's, oops. It's not args, it's options. Okay, I'm gonna rename this thing options. Okay, and we're gonna rename it across everywhere, and then we're going to go to all the places where we had it called args and rename it to options. Because I hate that. Rename symbol options. Okay, that's fine. That's actually, yeah, okay. So, all that to say, mode interactive. And I would love that to be just -I. I think that's sort of would be nicer. But we have to be careful. So, oh, okay. Foo. Okay, so we did mode interactive foo. That's so it's printing the command line arguments in the title. We hit Q and it exits. And I think that's a good place to stop for today. We're going to do this differently. So let's go ahead and make a commit. Dot and call it a day. Stub of interactive mode using Ratatouille, and then we can make this do the sort of UI that we outlined at the top of this module next time, and I think it'd be really interesting and fun because that's like half the point, right, of this stream. So thank you all for coming. I'm going to go ahead and push that, and then we will reconvene next week. And I will not have a bandage on my head next week.